How's it going, everyone? Welcome. Eulier Gonzalez here. And what I want to do in this video is to be very succinct about how do we get here, to briefly explain now what is this video and this series of videos about, particularly to understand and take notes of the book that Kyle Simpson, a software engineer, has released based on his experience of over 20 years of experience working with JavaScript, now understanding several main concepts that are important, especially as a JavaScript developer, to be a competent one. So to avoid suffering at least in your domain, in your profession, by understand the truth. All right. So because of that, this is why in this book, which is made of four models, the first model is about the get started, which is something that we are here right now. The second is on the scopes and closures, something that I want to dive deep into this. Uh, the third model is about types. Let me see, is that actually have the? Let me see if I am telling you the right order. I think I do. I think I do, but in any case, I don't want to. So yeah. So what is JavaScript? Again, this is the first model that gets started. All right. But the preface, I think it's a preface. You're talking about here is the part. Let me find that out here. That's interesting. Okay, yeah, this is the mission. The case doesn't really need to be made for why developers should take JavaScript seriously, which is exactly what I actually made that statement before. So, what I did that statement before. So, this is quite interesting. Where is the get started? In the get started, it's describing here, but it's describing is per model. Oh, in any case, let me see if this actually. Oh, Brian Holt. Holy moly, we're talking about. I know this dude. I know this dude. Anyway, forward. Oh, because I. Oh. This might be quite interesting to read about it. The first time I saw a tweet advertising the crowdfunding campaign for the original book series You Don't Know GS, I thought to myself that whoever the hell this Kyle Simpson is can get banned. Of course, I know JavaScript. At the time, I have been working in JavaScript for many years with some of the tech biggest name, so I felt justified in looking down my nose at this sweeping claim. Once the funding of the book completed, I observed that a lot of people were really excited to read this book series and decided to go ahead and give it a shot. You know, you just to show everyone that I do know JavaScript. Just to show that I do know JavaScript. So once I dug into the and poured over the text, I experienced a profound mix of learning, surprise, and even a little anger. Cal has knack for saying something that challenged my worldview and making me think about it until I realized what he said was actually true. I'll never admit this to him though. So it turns out I didn't know JavaScript. I didn't know why I have adopted certain patterns. I didn't know why JavaScript behaves the way it does in certain situations, and I didn't know much of the nuance of the language that I assume I did. Many were things I didn't know I didn't know. Okay, many were things I didn't know I didn't know. That's quite interesting. And I was worse off as a developer for it. So for example, many things that I didn't know, it was about the strict mode. It was about, so far in my case, it was about the strict mode. It was about is truly the way how now JavaScript actually treat each file as a single model. Each single file is a program in itself, and that's something quite interesting to dive deep. Um, amount is now the the numeric representations that the language use, which is the IEEE 7054 spec. All right, that specific spec describes now the way of how we can represent number in the language and therefore in our memory. So we can work with that. This is something that I didn't know how that works. And the other is about the Unicode, the basic multilingual, the basic multilingual plan, all right, which contains all of the different characters that we are quite familiar, for example, in the English and Spanish and French and Western language or Latin language and its derivatives, as well as the uh, Arabic or Persian, and also is from the sub-Saharan in Africa. Also is for Slavic languages or Slavic alphabet, as well as the pinyin character like or the hand-based character, all right, such as the South Korean, Japan, China, or Chinese, uh, among also the Mongolian. And this is just to describe the something that I didn't know that exists, as well as the way of how now the language represent is characters. All right. So it means that, for example, this is known as the astral plane, and I really love about the name. The astral plane is describing is that, hey, you know what is good about is when it comes to represents now emojis, and why these emojis have a particularly weird, non-intuitive length. For example, like 2 or 4 or you name it, right? 11. So this is just the two things that I didn't know about this, and this is why I'm actually I'm recording this series of videos to take notes out of this. So that's quite interesting. Now this formation, this is what this book series is great for. It's not just someone picking up the language for the first time, though it is for them too. It is for the software grasp people who want to master their tool, who wants to avoid any suffering about that, and to do that is by understanding. Who wants to understand the ins and outs of a trade and wants to select the proper method for solving problems. The thing I appreciate about Kyle and his work is that he is delightfully uninfluenced by the zeitgeist of the programming world around him. That isn't to say he isn't aware of what is happening in the community, but rather that it doesn't sway his pursuit of the best answer to correct question. This often has put him at odds with the latest best practice, but in reality, this is exactly what you need: a perspective removed from temporal influence and simply speaking from the underlying truth. That's why this series is so good. The first edition of You Don't Know GS is still accurate years later. Not many things stand this test of time given the shift sands of the JavaScript landscape. Given the shift sands of the JavaScript landscape, and especially in technology, the shifting sands. It is. So let's talk about this first book itself. Get started. You may be tempted to skip it as you might think that you already have gotten started. but it's worth reading this one. You'll be surprised how much depth, nuance, and oddity there is in the underlying building block of JavaScript, and it is quite essential for you to grapple with these underpins before venturing forward into the construct of the language. It is exactly the sort of foundation you need, you really to know JavaScript. So do your future self a favor and dig into this book and unlock the knowledge within. This solid foundation will serve you better than any framework ever will. And it's exactly the reason why it is. Those come and go, but we'll still be writing JavaScript itself for decades to come. Come on open mind and challenge your preconceived notions, because as I find out myself, you probably don't know JavaScript yet. Senior Program Manager, Visual Studio Code and Node.js on Azure in Microsoft. That was when he was working at Microsoft 6 years ago. Oh my god. So in any case, but the book is organized in this four. Yeah, the book is organized in this. Let me see if this one titles. Exactly in this one. So you have now the Sing and the Sing was cancelled, as well as the ES Next and Beyond. But I do think that they get started, the scope and closures, and the object and classes and time grammar are something that is important to dive deep, and that's where I'm going to look at the language in itself. And the chapter 1 to describe briefly is this, because in today's video I want to is explore about is the strict nature, as well as the second chapter of this. So here we're talking about is that what is JavaScript, who made the JavaScript, Brendan H. when he was working at Netscape, and since back then they know this language as with the code name as Mocha. For those who are familiar with Mocha as a testing library, that is no longer, because it was absorbed by all of these other frameworks to make things much more faster and compelling. But yeah, Mocha. But that language was known internally in Netscape as LiveScript. So because this name was an artifact of marketing shenanigans, okay? Since they want to position the language as a lightweight alternative of the heavy lift of the heavy in complete language known as Java, all right, as a lightweight alternative to that. So because even though that you must, if you're going to work with the language in itself, like Java, you need to know about is C and Java and things like the block scope. You need to get yourself familiar with this so you can reuse some of this knowledge to get into the language. And because the language right now is owned by the Oracle as through a series of acquisitions. So Netscape was acquired by AOL in November 1998, and then AOL was acquired by Microsoft Systems, and the Microsoft System was acquired in 2009 by Oracle. All right. So despite all of this series of acquisitions, the trademark has never been imposed, and quite frankly, at this point, is something that is not feasible. So even though that the legal name of the trademark is known as JavaScript, and the specification of the language, which is ECMAScript, that is overseen by a group of people known as the TC39. This is TC39. They now are people that come from different web related industries, such as the browser vendors or uh, device makers as well. So, for example, like Samsung. So, since these people, all right, now uh, actually oversees is the language in itself, or the technical specification is that how the language should behave, all right. Uh, Regardless how do you call this, whether it's JavaScript, ECMAScript, or ES6 or ES, and the name of the year, all right. All of them refers to the JavaScript, and there is something interesting to uh, yeah, there was something interesting that an Irish developer mentioned, Jeremy Keith, in 2009, that he say, well, Java is to JavaScript, holy moly, in 2009, bro. So Java is to JavaScript like ham is to hamster. In Spanish, esto es como Java es a JavaScript lo que Sol es a soldado. Correcto. Correct. Entonces, with that Spanish reference, right? And what you talk about is the people that what is the job of the TC39, which is not only overseas is that the language specifications, all right, and also proposal champions or proposals that since it has now 5 stages that as a programmer, since we started to count from zero, it started from stage 0 and then all the way up to stage 4. So you can be part of the pre-stage 0 discussions of what is the proposal that you're gonna be that you would like to have in the language, but it is up to the people who actually be part. So only those proposals that meet in the or only those people that get into that room of the TC39 and their proposals come along with are the only ones that are we look at the light in the spec, right? So because this is usually hosted by the company of these different folks, and some of them may receive some sort of compensations to be part of the team, right? The point of this is that even though that they define its specification, is that how now the JavaScript implementation must follow that, because they don't know the reality of the web. And this is not to blame on them. It's because JavaScript doesn't have 10 years. It actually is now a very grow old individual, right? It's like 30 years old, the language. So because of that, and the reality of the web is sometimes different to the reality of the spec, all right? And sometimes some JavaScript implementators, JavaScript engines say, hey, I'm not going to follow that, all right? And therefore, what you're gonna do is to ignore that. And then now in a specific, there is a specific, here you go. There's a specific appendix in the spec, for example, like this. Additional ECMAScript features for web browsers, which is describing is the content of this annex is normative but optional if the ECMAScript host is not a web browser. So this is when it started to describe is how it's supposed to behave. This annex describes various legacy features and other characteristics of web browsers based on ECMAScript implementation. All of the language features and behavior specified in this annex have one or more undesired characteristic. And in the absence of the legacy, usage will be removed from this specification. However, the uses of these features by a large number of existing web page means that the web browsers must continue to support. So there is still now a lot of websites. It doesn't, unfortunately, doesn't describe the ratio that is continuing to use all of these legacy features or features that that has some undesired characteristic. All right. And therefore they need to actually find a way to continue to support them, right? So these features are not considered part of the core of the ECMAScript, you know, and programmers should not use or assume the existing of these features or behaviors. So this is all of these things as it is, right? So it's describing is some of this behavior, HTML like comment, something like this. So for example, in the comment, we're quite familiar that this is one single line HTML open comment, so forth and so on, so some regular expression. But the point of this is that we are quite familiar to this. So the idea of this is just to describe that despite that some JavaScript implementations actually doesn't want to follow some of this spec by the ECMAScript, sometimes the ECMAScript actually now have to go back to the drawing table to, well, to refine some of this proposal or champions. A good example was with the name of includes, which is the way of how you can detect if there is a particular element in this collection, right? So include is one of them. The other is the where instead of calling that contains, it calls them includes, because there is a particular library out there that use that particular name. So yes. And another tragic and comic drama that happened in the JavaScript community was the mush gate, right? So when a particular feature for collections, they want to name that as flattened, but there is a particular library, I'm assuming that is in Germany, that they not only is use that named flattening to add it to the collections as a methods, but also is modifying it, it performs some DOM operations. So of course it was quite problematic, and they have to rename that to flat, right? So all of this is just things that are at least important to understand for a technical so for technical and for legal implications about using is the language, right? So when you now look at this mismatch between what happened with some JavaScript implementations and the ECMAScript, all right? And this mismatch is something that happened a lot of the time with JavaScript developers. I was one of them. Right now I'm continue to close the gap and skip that. But the thing here is that when there is an inversion, or when there is, which is something that even Kyle Simpson mentioned, when you find yourself thinking outside the way how JavaScript works, that's when you introduce a bug. And it makes quite sense, because if you don't know how the things works, sometimes that things will continue to work the way it does until it gives you something that is catastrophic or fatal. for your application, and that's why you don't want to do that. So in any case, so this is the language. This is the true the nature of the environments, all right, and these environments, all right, it's just as a way. So this environment is just is a way of how you can run your JavaScript engines, whether it's on the browser like this. Perhaps you're watching me through a browser, or you listen to me through a browser, or perhaps in a server, or in a light bulb, or in a computer, or in a robot. But the thing here is that despite of these collections of environments, the only reality that matters is the web. So because that, and when you're using, for example, is the when you're using, for example, now dev tools like the console, right, with this read event print loop, you might think that this is now running as a true JavaScript engine, or a true, and is following the ECMAScript. But the thing here is that it doesn't. And how do you know that this doesn't work? Well, so for example, that the normal behavior of JavaScript, according to the spec, is that when you create now a function, okay, say function one, right? And this is gonna say print, print color, right? So when you say color, so when you say return is now color, you get this, right? So I'm using is now is the template interpolations, yada yada. Okay, good. But the thing here is that when you now define functions and variables like this, you say, hey, color white, right? You say white. Both of these now are attached. So when you define a function or a variable in the global scope, both of them are attached to the global object called window here. So you can have access to those variables. So for example, you say print color, all right, and then you pass now the color, and then you can say window color color white, right? And then it actually works this. This is not how JavaScript works, all right? And also another example is that when it comes to hoisting, when it comes to use now the strict, all right, the directive call here, the use is strict. Okay, when it comes to use it, the directive uses strict, and when you use that, this will be used for the entire season, which is not true of how actually the directive works. So the directive can work is per file and per functions. So this particularly nuance here of when you are now using your JavaScript, you must be careful about this because so for example, you use a string like this, and since it changes the semantic of the language, so if you say something like color black, right, this doesn't supposed to work, you say black, you're gonna throw an error. Interesting that it works. So for example, if you say something like print color function here, say color, and then if you use something like this, you say use strict, all right, and then you do something like this. Let's say you say, well, color. You want to define now a color black. Say color black and say black. Black, right? And then you want to return is this. You say color. And this one, say color black. Come on. Color black. It's quite interesting that it's actually still using and allowing this kind of behaviors, all right, especially with the use strict. This is why we're going to look then in today's video about the use strict and that kind of stuff, because to me it's quite mind bending. I am not I don't know how it changed the behavior of the language. So in any case, but as a ways to guarantee is the backward compatibility of the language. So the TC39 actually say, hey, we want us to guarantee, we don't want to break the web. So therefore now we're going to is provide, or you have to, or we are going to create some community libraries out there, create now this polyfill. So some shims as a way to now your newest JavaScript features actually works in all their browsers. So the thing here is that this is something that the community recommends, right? Use the latest syntax, and then let some particular toolings do the heavy lifting of transforming into something that can be understood by the vast majority of the browsers. And because these things of these transpilations, we need to understand is how the language actually works. What is doing JavaScript engine when you are now evaluating a code, and why JavaScript, sometimes some folks might say that this is an interpreted language, but the thing is that the language in itself is a parse, if it's a parse language. So if it is a parse, it is in spirit, if not in practice, a compile language. What does it mean is that instead of, because compile language is the way of how now you can tell a language to analyze statically the entire program for errors and for correctness. And once that is done, then it's going to usually generate some portable binary representation that can be run and distribute in that distribution, or in that architecture, in that OS. All right. So whether it, for example, is the .exe, .msi in Windows, or the .app, .ipa in iOS, or the .apk in Android, or the .deb in Debian distro in Linux, and so on and so forth, right? So because it's now a particularly program that lives on the OS that help you to now to compile that set of instructions into this portable binary representation of the program that is gonna sit on disk, all right? And when you execute that in that proper distribution, or the proper machine, all right, the proper architecture. So when you, for example, when you click on, let's say, Google or Firefox or Brave, whether it's on Mac or Windows or any Linux distro, right? So when you click here, that's that binary representation, that program that sits on disk. Now the OS mounts that in memory and then call that the processor to execute the program in the main memory, and this is known as a process. Why am I mentioning this? Because processes is also part of the understanding when it comes to describe is how the things actually works. So process is something that has a particularly feature or characteristic, which is this process has a well-defined memory, so one misbehaving process won't interrupt or corrupt or change or stop the execution of another one. All right. So this specific feature, which is something that, for example, when you create now your instance, for example, in Node, this is a common use case, right? So when you create now Node instance through the cluster model, all right, or when you, for example, uh, create is the, yeah, how do you call it? Mm, yeah. So when you do actually, yeah, when you do uh, so for example, the tabs, all right? So tabs in Chrome's actually is now creating is one single process behind the scenes. So that's why when, for example, if you have now a misbehaving tab, it doesn't corrupt or doesn't stop the execution of other, which is a great stuff. And because this particularly process has internal is so some couple example of the process, such as the program counter, which indicates at which line is currently evaluating the program, or the stack, uh, or the register 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 processors, okay, a processors registry, yeah, processors registry, all right. uh, so all of this now live inside of something called a thread, and a thread is a unit of execution that is defined by the OS that pass is certain amount of instructions to the processor to be evaluated at an X amount of time. All right. So because the responsible for this coordination is known as the scheduler. So the scheduler, which is uh, this way of uh, this program that switch on and off process and threads uh, into the processor, right? Because doing this process switching is something that is expensive, and not is it because it is expensive because it needs to keep track about is, for example, the program counter, the stack, also is the memory that was allocated for this process, as well as the virtual memory that it needs to allocate that, and some internal data structure of the program. So, for example, at the kernel level. So, unlike threads, where since they live inside of the memory, since they live inside of the process and they share now the memory. So the thing here is now they are less expensive, but even though that this process, this context switching is so expensive, so they are now an effort for some alternative to this. So one of them is uh, the fibers and the code routines. So you now at the application level must, and this is something that I would like to ask Claude to see if this is actually true. All right. Okay. The coroutine, co, 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 co routines and fibers are alternative to the expensive process known as context switching. Those processes rely on rely on the rely on periodically rely on periodically. All right, so those or those alternative rely on periodically yield control rely on periodically yield control, but at the application level by the code author. Or correct me if I'm wrong. Yes, you're largely correct, but let me clarify and expand on a few key points. Context switching expensive. Yes, traditionally thread context switching is expensive because it involves the OS kernel saving and restoring the CPU registry, memory mappings, and other thread states, right? So this requires system calls and kernel involvement. Cooperative versus preemptive scheduling. You're right that coroutines and fiber use cooperating multitasking where the cooperating. This is a fancy word to say cooperative. 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 How do you call it this? Cooperative. Concurrency? No. Cooperative. Multi-threading cooperative multitasking, where the code explicitly yield control via yield or await or similar construct. And this construct with preemptively multitasking where the OS forcibly interrupt thread. Application level control, exactly. The yielding happening at the application level. The programmers decide when to yield control, typically at input and output operations or logical breakpoint in the code. The key benefit to this approach is eliminate the overheat of the kernel mediated context switching, since switching happens entirely in the user space. The runtimes and library manage a pool of this lightweight execution context. Now is the runtime or the library that is managing is the pools of this execution context. Minor classifications. It's more accurate to say that yield at a specific point, usually when waiting for input and output at a natural breakpoint, or when explicitly code to do so. The timing isn't necessarily periodic, but rather event-driven or logically determined. The trade-off, the main limitation is that if the code doesn't yield, like CPU-intensive loops, it can block other coroutines or fiber from running, since there is no preemptive interruption mechanism. So your understanding is fundamentally sounds, they are indeed likewise alternative that switch scheduling control from the OS to the application level. Again, I mention is this is because it is now the responsibility of the developers to periodically yield the control of the execution. Exactly. To control. So, but the point of this is quite interesting. Is that so? The thing here is that we are now, by describing is how this particular language actually works, and have now this image of understanding about this, is that when it comes to compile languages, all right, this is what happens. But the idea is that historically now the compiler language or the interpreter language has been saw as something that is with disdain, all right, inferior language, because they are not so performance that compiled versions. However, the point of this, or the heart of this lie, is on understanding now that the JavaScript in itself, or the core of this, is about how JavaScript actually handle errors. So this is a good example of that. What happened here now in interpreter language is that when you evaluating your code from line, let's say you have now 5 lines of code, at line 5, of course, if you have some particular errors, so in interpreter language, you have to go through all of this until the application breaks at runtimes. However, in compile language, all right, since this, what it does is to analyze the entire set of instructions first for errors in the process of tokenization, which is part of the compiler theory, which is tokenization, and then now go and recreate is this internal representation of all of this token that is decided by the language in itself, all right, which is by the time it's reading is keywords, identifiers or variables, values, operators, and so on and so forth. So now when it parses that, it tokenizes that, it then construct now a map for this. So this is pretty much like when you are reading a particular text, all right, especially if this text is in a language that you understood, you know what it's doing. You know what this text is actually meaning. It's trying to convey. It's trying to convey. And this is exactly what happened to the abstract. This is what happened. The language, by saying is, hey, we want is to now, once you already read the entire file, you create all of this token, we want is to now is to understand what it conveys to, what is the internal structure, what can we map to is, which is known as the abstract syntax tree. So this abstract syntax tree, which what it does is to, well, recreate or build is all of this stuff here, which is now this representation, this internal representation of all of the tokens, all of these instructions. Okay, so this abstract syntax tree is now then usually in compiled language is generating is this binary representation, these portable binary representations of the code that can be distributed around. But what happened here in JavaScript is this: when your text leave, or when your JavaScript file leave the ID, it's then transpiled to some different format of JavaScript code that can be widely executed by a lot of browsers, all right, by all the browsers possible, okay, and then pass through a series of bundling, right, or a series of build steps. It can be several that is now ready to be delivered. So when the JavaScript engines receive that, it's going to now parse that to detect some errors, syntax error, all right? And once that is done, and if everything went well, it's going to now take that and converting to a middle or intermediate representation of binary code, somewhat like bytecode, and then pass through the just-in-time compiler that live inside of the JavaScript engines to do some further refinements and optimization. And once that is done, then is when the code is executed. So because of this, in essence, and we can actually check, you can actually verify that by defining is some things here, and I actually not going to define that. So for example, you can say is let's say define some now value, or say name, right? And here you can say, well, my name is Moliere, right? And then, well, I want to put now here is my age, which is 35, all right? And look at this. So what happened is that first, the JavaScript engines, even though that this is a friendly JavaScript engine, is behaved somewhat as it is. So it actually parsed that, and then is when it's going to execute your code. So JavaScript, in essence, if it's not in practice, is a compile language. So once we know that, all right, and this is something that go beyond of JavaScript, but I think this is quite important, especially since this nature of this parsing and the interpretation language, because there is a concern about now how JavaScript can parse and execute code fast as possible. So a group of engineers in Mozilla in 2013 actually say, hey, we want us to make an experiment of trying to port this code from the game, all right, from the Unreal game into the browser, and it turns out it runs that game at full 60 FPS, right? So because this subset of JavaScript was not meant to be authored by developers, and in fact it was some hints that they passed through the JavaScript engines to do some optimizations. It shows that the capability of the language of running now programs that are in different language on the web, right, on the browser. And because of that, years has passed, a couple years later, now the ASM, which look at that, it's also some engineers at Mozilla, so they look at that and say, we want to take not only the ASM, right, as we want to take the spirit of ASM, but also make this library or this language, right, or this interpretation, we want us to now skip the parsing phase. So this language, which is completely different to JavaScript, it resembles to assembly, all right, where you have to move register one and there to actually perform some operations, all right. So when you do this kind of stuff, now WebAssembly shows the possibility of not only to describe is the language in this intermediary representation, but actually is act as a target compiler. So this is why now was has been used as a target compiler for any language. All right. So ASM is not an intent to replace is the JavaScript, as a lot of people actually suggest, and in fact, it's just an attempt to, well, is a universal target compiler. So whatever code you're gonna pass through this, whether it's C, Java, whatever it is, you can decide is what is the target compilation of that. So you can think of this. So is was a transpiler? No, right? It is a universal compiler target. It's not a transpiler because the compilation target and runtime format. So the output of that, a transpiler converts source code from one high level language. Was, on the other hand, is a low level bytecode format that serves as a compilation target for multiple language. So WASP is a compilation target. It's a universal compiler target. So in other words, WASP is a representation. WASP is a assembly like representation of the code. So in other words, was is an assembly-like representation of the code for the web and beyond. So WASP is indeed WASP is then an environment execution. WASP is both bytecode format and the execution environment. Okay. It's similar to the Java virtual machine. Okay, that's mind blowing. So when you have a WASP runtime, like in browsers, Node.js, WASP time, and WASR, you are running a virtual machine. That. Okay, so WASP is like JavaScript. Is like JavaScript in the browser, or JavaScript in the JavaScript in the browser, JavaScript in the server, and so on. Okay. Yes, that's a great analogy. WASP is like JavaScript in that its portable execution format can run in different environments. Exactly. But WASP has its own runtime. Browser, building all modern browsers, server, HCDN, blockchain, embedded, interesting. That is a mind-blowing thing. That is a mind-blowing thing of this. Okay. All right. Okay. it provides now an environment. That's okay. Okay. All right. Hmm. Exactly. Just like JavaScript, that is has its runtime, whether it's the browser, the server, the desktop, or the mobile, was has its own runtime. Mm-hmm. That is a mind-bending stuff, bro. Okay. Mm-hmm. That is a mind-bending stuff. So was give you the right ones that run anywhere. Portability of JavaScript, but with better performing near native speed and access to system language and their ecosystems, smaller binary size for complex applications, and deterministic execution. It is like having a universal runtime that is not tied to any specific programming language. Exactly. It's like you having now an environment that is not tied to any specific language, whether it's Java, whether it is C++ or Java. It is. Mm-hmm. So you write your JavaScript to target this environment. Was you're writing C, C++, Go, Go, etc., and compiled to Wasp to target this environment. Because you want to target those environment. You want to target is Wasp environment. So, 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 can you provide a single example of this? Compiled to Wasp, Rust target was exactly. Exactly. So you're telling to the compiler of that language, hey, compile to this. Now, this same Wasp file can run into multiple environments. Mm-hmm. Instance Fibonacci. Standalone runtimes Wasp time. Python using Wasp Py. But again, this go beyond the scope of today because that's interesting, alright? But what we really care is to understand now the strictly, okay? Strictly speaking. So back in 2009, with the release of ES5, JavaScript added a strict mode, right? As an opt-in mechanism for encouraging better JavaScript programs. So the benefit of the strict mode far outweigh the cost, but all habit die hard, and the inertia of existing, aka legacy, codebase is really hard to shift. So sadly, more than 10 years later, strict mode optionally means that it's still not necessarily the default for JavaScript programmers. So why strict mode? Strict mode shouldn't be thought as a restriction on what you can do, but rather as a guide to the best way to do things that the JavaScript engine has the best chance to optimize it. I think that I wrote it here. Backward compatibility, what is interpretation? And strictly speaking, exactly. So something that he mentioned here. Okay, so back in 2009, this was when Oracle acquired the trademark of JavaScript. With the release of ES5, JavaScript added strict mode as opt-in mechanism for encouraging better JavaScript progress. The benefit of a strict mode far outweighs the cost, but all habits die hard, and the inertia of existing, aka legacy code bases, is really hard to shift. So sadly that more than 10 years later, strict mode optionally means that is still not necessary by default for JavaScript programmers. So why strict mode? Strict mode shouldn't be thought as one of the restrictions of what you can do, but rather as a guide to the best way to do things so that the JavaScript engine has the best chance of optimizing and efficiently running the code. So the strict mode, strict mode, which was released in ES5 back then in 2009. All right, back then in 2009, exactly, as a mechanism for encouraging better JavaScript programs. Okay. Yep, strict mode, which was released. No. Strict mode was released. No, stop. In ES5 back then. Exactly. So strict mode was released in ES5 in 2009 as a mechanism for encouraging better JavaScript programs. But all habits die hard. And it is interesting. And this premise is a sacred cow for a lot of the society. All habits die hard. How that sentence, how that concept is benefiting you, is helping you to get the thing that you would need to do. You know what I mean? So this is why I actually ditch a lot of other misconceptions and so on and so forth, man. A lot of these thoughts and things, all of this stuff that are detrimental to myself. Absolutely. Anything that is detrimental to myself, throw out of the window. But all habits die hard. Right? And sadly, more than 10 years later, strict mode optionally means that it's still not necessary the default for JavaScript programmers. I was one of them. Sadly, more than 10 years, perhaps right now is more, sadly, more than 10 years later, strict mode is not strict mode is not a JavaScript option, or it's not a default. It's not necessarily the default for JavaScript programmers. So why strict? Why strict mode, right? So strict mode shouldn't be thought as of a restriction of what you can do. So strict mode shouldn't be thought as a restriction of so strict mode shouldn't be thought as a restriction shouldn't be thought as a restriction of JavaScript. Should be thought of as a restrictions of JavaScript. In fact, it is a guide that to the best way to do things. In fact, it is a guide to the best things to do with JavaScript to optimize, to have a best chance, to has a best chance, exactly, to have a best chance of optimizing and efficiently running the code, exactly, to have the best chance, to have a best chance to optimize and run efficiently JavaScript code. But it's just because it provides some hints. Okay, it's the best chance of optimization. Is to have the best chance to optimize and run to have a best chance for optimizing and running efficiently JavaScript code and run efficient JavaScript code. But it's that chance. It's that chance. So if you follow these particular rules, you are now providing hints to the JavaScript engines to efficiently run your code. For optimization and efficiently run your code. Okay. Most JavaScript code is worked on by teams of developers. So the strictness of a strict mode, along with tools like linters, often helps collaborations on code by avoiding some of the more problematic mistakes that slip by in non-strict mode. Most strict controls are in the forms of early errors. Exactly. Most strict modes controls are in the forms of early errors. And there you got it. So most of the strict form are in, or most strict mode controls, most of strict mode controls are in the form of error detection, or in the form of early error, or of early errors, meaning errors that aren't strictly syntax error but are still thrown at compile time before the code is run. Meaning they're not syntax errors. Exactly. Meaning errors that are not syntax error, meaning errors that are not syntax errors that are not strictly syntax, all right, but are still thrown at compile time, but are still thrown at compile time or at parsing time. So before the code is run. Exactly. Before the code is run. For example, the strict mode disallow naming two functions parameter the same and result in an early error. Some object strict mode control are only observable at runtime, such as how this default to undefined instead of the global object. Rather than fighting and arguing with strict mode, like a kid who just wants to define whatever their parents tell them to do not to do, the best mindset is that strict mode is like a linter reminding you how JavaScript should be written to have the highest quality and best chance at performance. If you find yourself feeling handcuffed trying to work around strict mode, that should be blaring red warning flag that you need to back up and rethinking the whole approach. Strict mode is switch on per files with a special parameter. Nothing allowed. Okay, strict mode is switch on per file with a special parameter. Nothing allowed before is except comment in white space. Only white space and comments are allowed. Before they use a space pragma. The rest of the file run in a strict mode. Exactly. Strict mode is switch on per file. Or it can be also per So this is a good example of this. This is mind-bending stuff. So for example, if you say function, and if those function has the same name, all right, which is quite duh. Let's say function, you say name, a name, right? And here you say, hey, use strict, and then you try to console log the name. It's a duplicate parameter name not allowed in this context. You can also say, hey, you can remove this, and it will of course not log that because you haven't passed anything. But it doesn't return you this kind of errors, for example. And this might be quite silly, all right? This might be quite silly. But now use a strict also is so you may say this is silly. This is silly. So some examples of this, all right? Some other strict mode. Meaning errors that aren't strictly exactly. Strict mode is allow naming two functions parameter the same. So what are or list the things that strict mode do in JavaScript. Variable declaration enforcement prevents creating global variables accidentally on declaring variable throw reference. Exactly. without var, let, or count, throw an error instead of creating a global one. But this is something that if you do this, use a strict, right? For example, say, hey, color, and you say white, say black. It's like, hey, color is not defined. Another example is this. So if you define with this, it's interesting because now it leaves as that. Assignment restrictions, function parameter rules. This behavior change in function, this is undefined instead of the global object. Prevent accidental global object modification. This is interesting. Reserve words cannot use future reserved words as in identifiers. Implement, interface, let, package, private, protect, public, static, yield, with statement, which is something that you don't actually use this. Completely prohibited. Throw syntax error. Eliminate the confusing scope within of with. And the eval. Variables created in eval don't link into the surrounding scope. Cannot assign eval identifier. And performance optimizations. Enable JavaScript engines to perform better optimizations in certain dynamic features are restricted. You enable it with user strict. But this just cases. Alright? So that this behavior change in function, this is undefined instead of the global object. And that's interesting. This is mind-bending stuff. So in functions, so in function is something like this. Interesting. In functions. Functions parameter rules. So exactly, this behavior change in functions, this is undefined instead of the global object. So for example, you say function, let's say check this, and when you call this and say console.log, remember that at the end of the day, this is a friendly JavaScript environment, not a fully JavaScript environment. So by the time that you call this, check this, it will now print the window error, so window object. But if we add now here, for example, like this, it's a use strict, and it is per season, and it changes the behavior at runtime. That is another mind-bending stuff, bro. That is another mind-bending stuff, bro. Mhm. So. Some of the behaviors that change, all right? Some of the behaviors, right? So, for example, strict mode, uh, examples. In a strict mode, uh, in a strict mode, functions parameter parameters named cannot be. Mhm. So in strict mode, functions parameter names cannot be the same, or the value of this. So the value of this, so the value of this uh, is undefined when using inside of the function. That is mind blowing, bro. Yep, that is mind blowing. Why doesn't it open up? That is mind blowing, bro. Okay. Okay, so it changed. So it became way much more deterministic. It is deterministic. Exactly. Before mechanical stuff. conoces el aguacate. De 10. De a 10. De a 10. De 10, mano, de 10. No, pero o sea, eso, 3100, 3200. Eso en calorías. Yo honestamente, si el plan fuese joven, marico, yo preferiría que estuviera saliendo con un viejo que la tuviera clara, güey. Yo preferiría que estuviera saliendo con un viejo que la tuviera clara, güey. Clara. Claro, no como un... No. Bueno. Estoy beginning to supervise. You know, it's like... Bomba de tiempo. Bomba de tiempo. All right. So that's strict mode, right? That makes a lot of sense with strict mode. That makes a lot of sense with strict mode. Okay. So, well, that'll be all for this video. Take care. Bye bye.